Okay, it's recording now, yeah. I need to, it's a different platform, so I need to take to the new situation. Okay, arithmetic sequence. Arithmetic sequence is a topic that we study. Arithmetic sequence. It's a sequence in which, for example, we have a common differences. We have D, que D is a common differences. Very important. Si no common difference, entonces no arithmetic sequence. And the A sub n formula is A1, que is the first one, plus A minus 1 times D. Okay, this is super important formula. But today we study another important formula, que is the summation. Suppose que I have summation, let's use a summation symbol, no? A sub k, and k starting 1 to m. So it's possible to prove, but I don't want to prove. Okay, the formula is A1 plus AM divided by 2, multiplication by n over 2. Or by n, multiplication by n. But let me manipulate in other way, using bracket maybe. Is n over 2 bracket A1 plus A sub n. It's easy. You take the first one, is this. You take the last one, is this, and you average, adding and divided by 2. And multiplication by m. And n is the number of the terms that you adding in the summation. Okay? Well, let's see example to apply that formula. Suppose, example 1. Suppose I need to add in 60 plus 64 plus 68 plus 72 plus continue in the same pattern plus 120. Compute that. We can do that. We expand, but I have no idea how many numbers we have. Okay, first of all, proof que es geometric sequence. The common difference is 4. Look, 64 minus 60, 68 minus 4, 72 is 4. So the common difference is 4. Okay. Who is the first one? A sub 1, 60. Who is the last one? A sub m, 120. But I don't know m. How many terms we have here? M. I don't know. The only guy I don't know in the formula is m. That one. Okay, but I can't find. I can find because I using my famous formula, the first one. Look, the first formula, this formula. This formula say A sub m, A1 plus n minus 1 multiplication by d. See, I assume that A sub n is the last one, okay, 120, because I want to find how many from the first to the last one. This is 60 plus n minus 1, I have no idea, multiplication by 4, get the common difference. And so for m. This is 120 minus 60 divided by 4. It's 120 minus 60 divided by 4 is 15. And 15 is equal n minus 1. Therefore, n alone is 16. N alone is 16 because I move the negative 1 to the left, 15 plus 1, 16 is there. I discover okay, this summation, okay, having my problem have 16 elements. This guy is 16. And therefore, instead to do the stupid thing, here in the calculator 60 plus 64 plus 68 plus 72, enter, done. Where the next? The next is 76. No, you plug it in the formula. The formula say summation this sequence from 1 to 16, because I discovered we have 16 elements, is 16 gets m, look at that formula, divided by 2, bracket, 60 plus 120. This is 8, 16 divided by 2 is 8, and this is 180, no? A multiplication is, let me see in the calculator, 180 times 8, yeah, 1,440. Do you understand very well the formula?
Yeah.
Okay, let's do a couple more of the example. And you help me to understand this. Example 2 is 4 plus 4.5 plus 5 plus 5.5. Entonces this is enough to understand what's the pattern. The next is 6, 6.5, and so on. So I put symbolically like that. 3 dot 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 indicate que continue forever, and the last guy is 100. Okay, what do you think? This is arithmetic sequence, yes or no? This is arithmetic sequence, yes or no?
Yes.
Yeah, and what are the common differences?
0.5.
Absolutely. Now he subtract this 4.5 minus 8.5. 0.5. This is the common difference. Who is A1? Who is A1?
4.
4, the first one. And who is the last one?
$100.
100. Actually, I need to condense in this summation in one summation, que start in 1, always start in 1, to m, okay, I have no idea how many elements we have here. I need to discover this m, I don't know exactly, of the a sub k. And the formula is this formula. Is, look, m divided by 2, bracket, a1 plus am. Okay, to find m, we're doing similar to the another problem, no? To say I know que a sub m is equal a sub 1 plus a minus 1 times d. A sub n is 100, a1 is 4, plus a minus 1 multiplication by 0.5, que es d. Okay, so now I move for subtraction, 100 minus 4 divided by 0.5. Okay, divided by 0.5 is the same multiplication by 2. 100 minus 4 is 96, no? Divided by 0.5. Wow, it's 192. And this is equal to n minus 1. Therefore, n is 193. Wow, entonces this summation contain 193 elements from 1 to 193. And we come back to the formula for the summation is 193 divided by 2, bracket multiplication, and a1 is 4, you remember that, no? Plus the last one is 100. Okay, entonces 100 plus 4 is 104. Divided by 2, 52. And 52 times 193 is 10,000. 36. ¿Es easy o no? Everyone understand very well this or no?
Yes.
One more example, right? To practice a little bit. Suppose example 3, and you help me. Example 3 is A plus A 1/4 using mixed number plus A 1/2 plus A 3/4 plus 9 plus bam 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 250. Okay. The question say first of all, what is arithmetic sequence, yes or no? And si the answer is yes, what are the common differences? Help me. Yes or no? No?
Yes.
Yes. And what are the common differences?
0.25.
No. No. How you find the common differences? The common difference is the formula A sub n minus A sub n minus 1. So you add, subtracting any position minus the previous. Okay, you subtracting this minus this. What is the subtracting? A 1/4 minus A. What is the answer of this? I don't know, put it in a calculator using your common sense, no?
0.25.
0.25 is 1/4, of course. Of course, 1.25 is 1/4. So it's obvious que 1/4, no? What you subtracting the whole part. A minus A is 0, 1/4. And this is exactly the same 1/4. You see or no? Because A minus A is 0, 1/2 minus 1/4, 1/4. 1/4 is the common difference. Clear? Clear? Any question on the common difference?
Clear.
Who is A1 and who is AM? Is the easy part. Who is A sub 1?
8.
8. Very well. A sub M? I suppose que es 50 is the last. So the first and the last. In the formula only participate first and last. Okay, what is my formula? Well, my formula is, I copy it one more time, is summation from k equal 1 to the n, I have no idea, of the A sub k. I can find the formula for this. I can, why not? And this is equal n over 2 bracket A1 plus A sub n. As you want to find the number of elements, well, we use one more time the formula A sub m is equal to A1 plus n minus 1 times d. A sub n is 50, A1 is 8, plus n minus 1 multiplication by 1/4, 0.25 if you want in decimal. So actually 50 minus 8 times 4. Because when you move that 4 like a cross multiply, no? Is n minus 2, n minus 1, sorry. Entonces 50, 50, 50, 50, 50, 50 minus 8 multiplication, 42, multiplication by 4 is 168, therefore n is 169. Okay, so my summation is from 1 to 169. And my formula is equal 169 divided by 2 bracket 8 plus something plus 50, no? 50 plus 8 is 58. 58 divided by multiplication, it doesn't matter the order. 169 divided by 2. And the answer 4,901. 4,000, no, 4,900, yeah, usually. 900. Okay, do you understand very well how we manipulate arithmetic sequence? No problema.
No.
Let's move on to the geometry sequence. It's another kind of important sequence. Did you say something? Okay, geometry sequence. We studied geometry sequence. Geometric. Okay, period. Okay, it's another important sequence. Can you apply in the real life? How do you know geometric sequence? Well, geometric sequence is, let me bring an example. Suppose we have 4, 16, 64, let me try. $256 and so I have no idea. When you're subtracting, no, it's different answer. But when you divide, this is the idea now. You take this and division 16 divided by 4, F4. And you divide here 64 divided by 60, F4. And 256 divided by 64 is also 4. So we have no common difference. It's common ratio. Common ratio. When you have common ratio, then this example is 4, and common ratio is indicated using letter R. Common ratio. It's geometric sequence. And the proof is a common ratio is divide any element by the previous, if the answer is constant, entonces geometric sequence, and you find the famous common ratio. In order to find the general formula, the A sub n formula, and the geometric sequence equal the first one, A1, times common ratio n minus 1. This is the formula. Similar formula of the arithmetic but in this case geometry to set a power. So suppose in this example, introductory example, so you want to find the formula that describe this sequence A sub m, explicit formula A1 F4, and the common ratio is a coincidence of 4 n minus 1, something like that, right? But leave it like that. No, because you multiply this, please. This is 4 to the 1 power, and this is 4 to the n, no? Because you adding the exponent, n minus 1 plus 1 and 4 to the n. That makes sense, because for n equal 1 and 4, for n equal 2 is 16, because 4 squared, 4 cubed is 64, and so on. Okay, clear the formula? Let's practice one not too easy example. Not too easy. Okay, suppose this example. Suppose 10. Example 2, no? Suppose 10, comma, 9, comma, 81 over 10, comma, 729 over 100, comma, bam, 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 bam. So the job is determine if it's geometric sequence, yes or no, and what is the common ratio. And the common ratio is easy. Is you divide common ratio, you divide R, you divide 9 over 10, no? And put in decimal or put in fraction, either way. And another test is you divide this divided by this. Is 81 over 10 divided by 9. Well, this is the complex fraction. So you copy the fraction in the numerator, multiply by the flipped, the fraction in the denominator, and you can see clear. And you can see clear. You can see clear that 81 divided by 9 is 9. So you cancel out this 1, and this is 9. And let's say 9 times 1 is 9 over 10. Wow, fantastic. Look like same value. Look. And we try one more time. You divide this, and you divide this. So this is a little bit more complicated, but you use calculator. No? Common ratio is R. 729 100 divided by 81 over 10. Entonces 729 over 100 times flipped 10 over 81. Cancel out 1 0 here, stay 10 in the bottom, exactly we need, look at that. And you put in the calculator 729 divided by 81, let's do it quickly. 729 divided by 81, what? Wait, it's 729 divided by 81, 7, no, 7, carajo. 729 divided by 81 and 9, super. And what a fantastic conclusion, okay? The common ratio is the same, therefore this is geometric sequence. Okay? Entonces the formula for finding any term of the geometric sequence is, well, okay. Suppose in this example, let me take advantage of this example. What is the formula? The general formula for this example. Well, the formula is A sub m is equal A sub 1, R, A sub 1, A sub 1, A sub 1, R, n minus 1. A sub m, A sub m, A sub A sub m is equal to A1, que A1 is 10, is the first in the sequence. Look, 10 is the first. And the common ratio is 9 over 10 raised to the n minus 1. And it's possible to leave it like that. We can simplification. We can simplification a little bit. How? Why don't you expand this as 10 times 9 n minus 1 divided by 10 n minus 1. And now you combine the 10 part. Okay, is subtraction. And this is 9 n minus 1 divided by 10 to the n, no? Now it is 10 to the 1 divided by 10 to the n minus 1. You subtract, it's 10 to the 1 minus m plus 1. And this is, but this, you change the sign minus. Minus is 10 to the 2 minus m. 2 minus m. This is wrong. Is, this subtraction 1 minus this. Okay. Okay. Entonces 10 to the minus n plus 2. Much better. Okay. Oh no. Leave it at that, prof. Don't complicate your life. It's to be honest. Suppose I want to compute a sub 9. It's too big number, I suppose. Okay, entonces 10. 9 over 10 raised to the 9 minus 1, que es 8. Raised to the 8 power. Bueno, okay. I put in the calculator, hello. Because it's too much. The answer is 4.304671 and, no, 21, sorry, 21. And fraction. And decimal, in decimal, and fraction is no good. Do you understand the idea? Geometric. Okay, but I want to use the formula for the summation. Okay, summation, sum what? Sum the first element in the geometric sequence. Suppose A sub m. Who is A sub m? A summation from k equal 1 to m of the A sub k. So basically you're adding A1 plus A2 plus plus A sub m. But this is connecting by geometric sequence. So the formula for the geometric sequence. So the formula is that summation A sub m is equal A sub 1 parenthesis 1 minus r to the n power divided by 1 minus r. This is the most important formula for the summation in the geometric sequence. Okay? And depending of the common ratio. Let's see example. Suppose we have this example 3. In example 3, we have this sequence: 1/2 plus 1 over 4 plus 1 over 8 plus bam plus. I see that the formula is, looking the pattern, is 2 to the n, no? 2 to the n, something like that. 2 to the n. Making sense, because for n equal 1, 2 to the 1 power get 2 to n equal to 2 to the second power get 4, and so on. Entonces I need to find this summation. Okay. Entonces my question is geometric sequence yes or no? And in the case the answer is yes, what is the common ratio in that case? Okay. Try to answer my question. Is geometric sequence yes or no? In the case the answer is yes, of course yes, because we are studying geometric sequence, no? What is the common ratio? What is the formula for finding common ratio? What should I do here in the other example to find common ratio? You divide, no? You divide, no subtraction. In arithmetic subtraction. In geometry is division. You divide 1 over 4 divided by 1/2. Yes or no? This divided by this. 1 over 4 times 2 over 1. Flip it out. It's 2 over 4 get 1/2. The answer is 1/2. Let's do it one more. 1 over 8 divided by 1 over 4. And 1 over 8 times 4 over 1. And 4 over 8, and when you reduce the lower term, again 1/2. The common ratio is 1/2. Super. Entonces, what is the formula? The A sub n formula. No, the A sub n formula in general is A1 R n minus 1. Okay. And who is A1? A1 is 1/2. In our example, look at that. Who is the common ratio? The common ratio is 1/2 raised to the n minus 1. And that's it, yeah, that's it. Oh, no, much better. It's 1/2 times 1 over 2 n minus 1. Because you raise 1 to the n power 1. And when you multiply this and this, you get 1 over 2 exactly we predict using the intuition. Look. Entonces, what is the formula to add in this? The formula is this formula. That formula. And that formula we can apply in this example. Okay. The formula for the, suppose I want to add in curiosity. Well, no, in general. A sub m in our particular example is 1/2. Parenthesis, okay, A1 is 1/2. 1 minus R is 1/2, but raised to the n power is 1 over 2 to the n power divided by 1 minus 1/2. Something like that, right? Okay, 1 minus 1/2 is 1/2. Entonces 1/2, 1 minus 1 over 2 to the n divided by 1/2. And 1/2 is cancelled. And the formula for this specific example is 1 minus 1 over 2 to the n. Let me try another example to verification. Okay, this formula is good. Suppose I want to add the first 3 elements in this sequence. Okay, by the way, is that one, and that one. Well, you can do by hand, 1/2 plus 1/4 plus, okay, you can. Or using the formula, that formula, S3 is 1 over 2 to the third power. 2 to the third power is 8. It's 8, actually. It's 8. It's 8. Entonces 1 minus 1 over 8, ¿no? Ajá, entonces this is 7 over 8, ¿no? Because, let me see, you find the least common denominator, que es 8, is 8 minus 1, ¿no? Es 7 over 8, es the answer. However, si I do it by hand, because it's easy, because we have 3 elements, si we have 1000, it's impossible doing in the traditional way, and you need to go to the formula. 1/2 plus 1 over 4 plus 1 over 8. It's a 4. The least common denominator obviously is 8. 8 divided by 2 over 4 times 1 over 4. So 4 over 8 and 1/2 is the same thing. 8 divided by 4 is 2 times 1 is 2. And 8 divided by 8 is 1 times 1 is 1. Entonces 6 plus 1 is 7 over 8. Do you think it worked perfectly? Okay. Any question, guy? Are you too quiet today? Or it's easy or it's complicated? Come on, opinion. Everyone follow me or no?
Yes. Yes.
Matilde, it's okay?
Yes. Yes.
Yes, Matilde said, oh yes. You see me? Oh. Okay. Okay, now let me discuss in one new thing inside the geometric, of course. Is series. Determine whether geometric series. This is a new idea. I don't know what is series. I want to explain now. Converged, or no, divergent. It's another terminology using this idea. So I need to determine if the series converge or diverge. Converge or diverge. What are the series? Series infinity summation. Suppose that we have one intuition first. 1 plus 1/2 plus 1/4 plus 1 over 8 plus 1 over 16 is the next, no? Because you divide by 2, no, multiply by 2. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. What is the next? 32, no? 64, blah, blah, blah. I don't care. But it's infinity. My question is, the answer is infinity or no? Si es infinity, es diverge. Y si es a number, magic number, es converge. This is the idea behind converge or diverge. What do you think? Is converge or diverge? So you're adding infinity number. Of course, I take care that we adding a small, a little bit small number, and a little bit small number, and a little bit small number. Intentionally I did that, no? No, see, you adding 1 plus 2 plus 3 plus 4, it's obvious that diverge. It's stupid. But in this case, what do you think?
Diverges.
Diverge, definitely. Okay, the summation for the infinity number, always give me, I am not late. I am being meeting, but I took, okay, no problem, you see me. Okay. Okay, you see me, okay. The important thing is no late or no. The question, converge or diverge? Mr. Amores, no? I recognize your voice. Amore, are you the student that answer me always, no? You say get diverge, no? Es Mr. Amores, ¿o no? A ver, who answered me?
It was me, Professor.
Who are you?
Anthony.
Anthony
Suarez.
Okay. So you believe que es diverge, right?
Yeah.
Another opinion, guy. Matilde, what do you think? No idea, right?
I think it's diverge as well.
Ajá. Matilde say que agree with Anthony 100% que is definitely divergent because it's infinity number, right? That's the reason, no? However, you are
Yeah.
wrong. However, you are wrong. Yeah, I want to prove. Now, I want to prove using intuition first. No complicated mathematics. And after, I go directly to the formula. Pero okay. Suppose que we have a segment. I have no idea the length of this segment. And you take this guy first, 1. Okay, suppose que 1 here. That is. Now I take the second, 1/2. Well, 1/2 is addition. Addition means that you include more. So this you divide, split this segment. So this is 1/2, no? Do you follow me? So far we are doing that this time. Look, 1 get the first guy, and 1/2 get the second guy. Now, in the third guy, 1/4, 1/4. So you split this 1/4 again, and you add in this part. And the rest is, again, the same stupid thing. Split that 1/8. You see you're adding, but you're adding smaller, smaller, smaller. And you're adding, and you're adding. So now you change the mind. You believe it's convergent or divergent? The intuition, guy, intuition, no mathematics, no try, intuition. So you adding in the next 1/16 gets a half of this. And 1/32 gets a half of this. And 1/32 gets a half of this. So you see you're adding, that number is too small, too small, too small, too small. But it doesn't matter if it's small or no. In this specific example, you see that this converges or diverges. Do you understand the idea for the convergence? And the idea for the divergence? Tell me, yes or no?
No.
No, okay, don't worry, it's normal. Okay, this look like optics. Optics is the science study the light. So for example, you have different lenses like that. You use them to the eyes, no? One lenses. In this case, for example, the light, let me use the light yellow, no? The sunlight. Suppose that the rate of the sunlight is coming for the lenses. And the lens collecting and converging to the 1 point. By the way, this point is called focus. And I don't know, so you, for the child, you are doing this experiment. You take the lenses, okay, you use them to augment and to see the letter in the book big, and you put it in the sunlight, and you put it on a piece of paper, and you create fire. Do you see that one? You did that one? Actually, here, this is a paper, and you create fire. This is typical converging because the sun, the ray of the sun converges to 1 point. And this is completely opposite idea. This is diverging. Look, let me show you. The ray of the sun travel parallel because I suppose the sun is too far and diverge. This is the idea behind. So the mathematician taking this terminology and this phenomenon. This is convergent. And this is divergent. So see, my son diverge is because, you know, go to infinity, blow up, explode. However, see, my series go to the one specific number is convergent. Do you get the idea? Convergent, divergent idea?
Yes.
Do you understand very well the idea for the lenses? When you are a child, you working with the lenses or never? Never.
Yeah.
Ah, entonces you understand better, right? Okay, okay. Entonces, what do you think about this summation que I did by hand here, geometrical? Is converge or is diverge? Go to the one specific number or no? Go infinity.
Converges.
Converges. So you change your mind. Okay, Mr. Anthony. Now, I have an extra question for you. At what number converge? So what is the answer? No infinity. So, Anthony, change your mind. No infinity, professor. No, 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 no diverge. No, 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 no diverge anymore. No, no. It's converging, but I need to investigate what number here. Geometrical, you can see or no?
No, I don't know.
No, there's two. Look, this is one. This is 1.5. This is 1 3/4, right? And so on. This is 2. Stop at 2. When you add infinity fraction, no in general, and this particular problem I create for you to explain this idea, the answer is 2. Do you see now or no? A little bit, intuition. Intuition is the thing that you feel, pero you don't make sure. So the mathematics, you find, you divide, and the answer is 2. Entonces, I got it. But intuition is okay. So now, I come back to the formula que we use in the summation of the geometric series. Que the formula is A sub m, summation for the m first, is A1. And we have fraction here. It's 1 minus Rm, 1 minus R. Okay, entonces the idea behind this, well, let me split this in two pieces. This is A1 divided by 1 minus R, because it's the common denominator, minus A1 Rm divided by 1 minus R. But it's clear. It's algebra. But the thing is, I want S. Who is S? S is the limit when the n approaches to infinity, the infinity number of the A sub m. And when you apply the limit of this, that part is constant and it stays the same. It's a number, 20, 40, because do not depending of m. But this part, no. This part, you have two possibilities. Or go to infinity, que es diverge series, or go to 0, que es converge. And that depending of the common ratio. See the absolute value of the common ratio, absolute value because I don't care, que es positive or negative, is less than 1, converge. See the absolute value is greater than or equal to 1, include 1, diverge. But in our specific example, the common ratio of the geometric sequence was 1/2. You remember, right? 1/2. Look, 1/2. Entonces converge, pero converge to what number? This is a formula. Let me copy again the formula and compute that finally. S is equal to A1 divided by 1 minus R. And this is the sum of the infinity element. A1 is 1, que es the first one. Look at the first one, and this summation and this series is 1. And the common ratio is 1/2. 1 minus 1/2. Well, 1 minus 1/2 is 1/2, no? And reciprocal 1 is 2. Boom, is the answer. Do you see that? Okay, it's important. The new idea behind is series. Series is different to the summation because series you can represent like that. Let me show you. Summation from k equal 1 to infinity. Calculus 2 series. And the a sub k of this series is super easy to find. Well, by the way, is a sub k is 1 over 2 to the k power. Okay, I discovered that summation an infinity element 1 over 2 to the k is equal to. Wow, fantastic. Okay, let me try 1, 2, 3 examples. 3 examples of this. Okay, suppose. Determine whether the geometric series converge or diverge. Another example. Example 4. Example 4 is given this 2 plus 4 over 3 plus a over 9 plus down. Okay, it's a series. Okay, first of all, it's the one identification geometric or no. Step 2, okay, actually is containing the step 1 is find the common ratio. Okay, if the common ratio is less than 1, the series converging. Or why not? And step 4, and determine at what value converge. The formula is a1 divided by 1 minus r. Boom. Fourth step. Okay, let's do it. You divide 4 over 3 divided by 2. This divided by this. Is 4 over 3 times 1/2. Simplification a little bit is 2/3. 2/3 is the common ratio. Well, I don't know. Let me try one more at least. It's a over 9 divided by 4/3. It's a over 9 times 3 over 4, reciprocal. And now simplification divided by 4, 1, divided by 4, 2, divided by 3, 1, divided by 3, 2, is 3 over 2. Again. 2/3, sorry, 2/3. Entonces, for the first question, is geometry yes or no? The answer is yes or no.
Yes.
Yes. The common ratio, the answer is 2/3. And si es 2/3 less than 1, the actual value, in this case, have no sense to talk about actual value because positive, 2/3, is converge or diverge.
Converges.
Entonces, when you compute the summation from k equal 1, okay, k equal 1 is this guy, k equal 1 to infinity, because this continues forever, the answer, we have answer. Okay, the answer is a1 over 1 minus r. Let's do it. A1 is 2 and r is 2/3. Entonces es 1 minus 2/3, 1 minus 2 over 3. Okay, entonces 3 is the common denominator. Es 3 minus 2 is 1. Entonces 2 over 1/3, because 3 minus 2 is 1, 1/3, and flip that. And this is 3 over 1 times 2 is 6. The answer is 6. Wow, unbelievable. The answer is 6. The answer is 6. Do you understand or no? If the common ratio is no less than 1, it's obvious que no converge. And that's it, end of story. Okay. Let me explain one fantastic application for this formula. Suppose. Any question, guys? May I erase the board or not? Erase or not yet?
Yes, yes.
Okay. Okay, this is interesting. Pay attention, please. Suppose 0.6 repeated. This is a classical example of the infinity, no? Because actually this is 0.6 plus 0.06, no? Plus 0.006 and so on. No? It's infinity, yes or no? And what do you think? This diverge or converge? This is the dilemma.
It doesn't like converge.
Why?
And the ratio is 1.
No, the ratio is not 1. Let me try to explain. Okay, good. Maybe to see more, you divide. The common ratio, how you find the common ratio? The common ratio you find division, this guy divided by this guy, no? This divided by this, no? You divide 0.06 divided by 0.6 is 0.1. Yes or no?
Oh, yeah.
Oh, yeah. Okay, suppose to see more clear. I don't know if you see in fraction. This is 6/10. This is 6/100. Clear? More clear? This is 6/1000. Also. And the common ratio is 6/100 divided by 6/10. It's 6/100 times 10/6. 6 is cancelled, and this is 1/10. Same answer of this. Yes or no? Do you see?
Yeah.
Entonces, my conclusion is, bueno, I don't know, I don't compute this, but I suppose que it's the same. Yes or no? It's geometric. Yes or no?
Yes.
And converge or diverge?
Converge.
Why?
Because less than 1, the ratio.
The ratio is less than 1. So converge, but converge to what value? This is challenging. Converge to what value? Well, converge because the common ratio is less than 1. Okay, this is the reason that you can affirm que converge. Suppose que I want to compute in decimal. In decimal. The formula is A1 divided by 1 minus R, correct? A1 is the first one, que es this. Que es 0.6. And fraction is 6/10. You can reduce a lower extremity like a 3/5. Yes or no? A 3/5. Divided by 1 minus 1/10, ¿no? Que es the common ratio. 3/5 divided by 10 is the least common denominator, is 10 minus 1. And 10 minus 1 is 9. It's a 3/5 divided by 9/10. Now division. We copy the first fraction, exactly the same, flip it the second, 10/9, and simplify when it's possible. In this case, divided by 5/1, divided by 5/2, divided by 3/1, divided by 3/2. The answer is 2/3. And this is not new for you. If you put in a calculator, 2/3, and you divide, put in your own calculator now, please. 2 division 3, you see que 0.66666. Maybe in your calculator, give me the last digit like a 7, because the reason is que the calculator truncate and the last digit you can display. But actually, mathematical is 2/3. 2/3 is 0.6 repeated. Do you see or no? Do you see or no?
Yeah.
Okay. This is not new for you, no? And what about 0.3? Repeat it. Repeat it. No idea.
It's 1/3.
1/3. Very well. 1/3. How do you know? What is the reason do you know? Without do anything.
Because 0.3 is 3/10.
Because it's a half. You divide by 2 and that's it. Si es 2/3 divided by 2, no? Es 1/3, no? Make sense? Make sense, guys? Matilde, it's okay for you?
Yes.
And what about, listen to me, what about 0.9 repeated? What is the answer of this? Come on. Reward for the student to get that answer. No idea. We have a decimal que es 0.99999, infinity 9. What is the answer of this? Nobody? Anthony, no? Intuition, guys, intuition. So you make a mistake, no problem. Say one number, 20, 40, 100. Intuition. What say your intuition? No intuition? You have no intuition for the series. The answer is 1. Makes sense or no? No?
It doesn't make sense to me.
No?
No.
No. Okay. I respect. Okay, 0.99999 infinity 9.
Oh, I understand now.
You understand. You understand. I want to prove in a different way. Si you accept que 0.3 repeat is 1/3, if you multiply both sides by 3 and by 3, this is 0.9 repeated. It doesn't matter if you have infinity decimal. This is 1. However, no, suppose que no. I don't see that. This is unbelievable. Unbelievable. Suppose. Another way to see, or another point of view. Using series again. Suppose that you have 9/10 plus 9/100. Makes sense, right? Plus 9/1000. Plus infinity. This is 0.9 in decimal. This is 0.09 in decimal. This is 0.009 in decimal. What is the common ratio? Do you see the common ratio of this series, of this geometric series? What is the common ratio? You don't understand how you find the common ratio?
Would it be 0.9?
0.9, no. How you find the common ratio? You divide. You divide any element divided by previous. 9/100 divided by 9/10. Yes or no? It's a formula for the common ratio. Entonces, 9/100 times 10/9. 9 is cancelled, and it's 1/10. Exactly the same in the previous example. So you don't understand the previous example. Entonces, what is the formula? Entonces, converge or diverge? What do you think? The dilemma. Converge?
Convergence.
Exactly. How do you know?
because it's not gonna go into infinity. It'll become 2 or 1, right?
So that's it. You don't know if it go to infinity or not. This is the dilemma. And the indicator to decide si es converge or diverge is a common ratio. Si common ratio is less than 1, and then it's converge. Okay, it's obvious que yes, because it's 1/10. And the formula is S A1, 1 minus R. A1 is 9/10, okay, the first one, the first guy. And the common ratio is 1/10. Let's see what happens. Put together, least common denominator is 10. 10 minus 1, 9/10, divided by 9/10. The answer is 1. It's unbelievable or no? Entonces I have a question, the extra question. 0.6, 0.3, 0.9, and another example I have here, okay, 0.45, repeated 45. This is rational or irrational number? Or irrational number? Is rational or irrational number?
Rational number.
Absolutely, because by definition, rational number is the number that you can express it like a fraction. And it doesn't matter if it has infinity. Some people say, no, it's irrational, professor, because it has infinity decimal place. Okay, but repeated. When it's repeated, is rational. When it's non-repeated, like the famous pi, que es 3.14, 15, 9, non-repeated, those is irrational. And we never can express like fraction. Okay. Try to do by yourself. Stop here. 0.45 repeated. Express it like a fraction. Express it like a fraction using the same idea. Hints. You expand like a series. You determine the common ratio and apply the formula. And the formula gives me the answer in fraction. Okay, extra credit for this. 10 point extra. Extra credit. It's 5 point. Because this is 5 point. Okay, what is the answer? Boom. Okay, stop, guy. Okay, have a nice afternoon because I have now another class after this. Wow, too busy day I have. Bye bye, guys.
Do we email you the answers, Professor?
No. You attach to the solution for the test.
Okay.
Okay. Well, bye.
Have a good day, Professor.